Hello, I'm Mark Schildhouse, and this video is on 3D printing. Let me make this perfectly clear. First of all, I think it was 6 days ago that I completed the assembly of my Prusa Mark III S Plus, I think is the correct designation, 3D printer, and I've been playing with it since. I've had several successes, a few failures. I am not a pro in this. This is a beginning effort for me, and I had a lot of questions, and this video I think would have answered my questions if I'd been able to ask them if I knew what the heck I was doing. So let me get into this. About 2 years ago, and this is August 2021 because things on the internet last forever and they lose their timeline. About 2 years ago, I was in the San Diego Fine Woodworkers workshop doing a CNC course and saw a 3D printer off on the side and said, wow, that's like kind of cool. I had some other priorities along the way, and kind of cool, kind of interesting, want to see what it's about. So in the process of accomplishing other things and learning some about 3D printing, I took the San Diego Fine Woodworkers introduction course under the instruction of Travis Good, the current president and one of their chief instructors, the other day, and said, okay, I'm going to step into this. And the reason I stepped into it is multifold. First, I have one wife and one daughter that are both school teachers, and they would like educational support for their classroom, and this thing can generate a lot of material and do it very well. Next, I have at this time a 6-year-old granddaughter, Princess Lily Bean of Canyonland, who I absolutely love making educational toys for and developing her intelligence and her smarts. And this thing will do that. I have numerous hobbies, including model railroading, woodworking, a number of other things, and this will help me in that. So it's not just for one reason. So I expended the money, bought what I thought was probably the best value printer on the system. I'm not endorsing Prusa. If you have another option, go for it. I just thought, based on the recommendations I had and the research I did, this was a very, very good printer. It's turning out to be that. So what can you do with this thing? Because that's one of the curiosity things. Well, along the way, one of the sample files that Prusa gives you on the SD card, which they're very nice to give you with some basic files, is this guy here, this Batman thing. And it's kind of cool, kind of fun. It's just a toy. My granddaughter loves it. Princess Lily Bean loves this. And it's just, hey, you know, is your printer working right and whatever else. And it really shows some of the excellent detail they've got with that. Okay, I am a big Star Wars fan. Most of the house is a Star Wars fan. The Bean loves Kylo Ren. She's hung up on the bad guys. So this was on Thingiverse, and here's the URL for Thingiverse as text. And he's actually 3 pieces. This guy here, which I call the spine, is about 1/8 of an inch by 3/8 of an inch, and he holds his head to the body. And that took about 8 minutes to print. It's not that big. It took about 8 minutes to print. One of the first lessons learned in this is not a fast process. Here's the head. It's not solid. It's honeycombed, as a slicer will do to save printing time and filament and weight. And that took like 3 hours. So kind of fun. Then we end up with the body with the cape. And I had what's called brim put on it to add support. Broke that off. It comes off really easy. You'll see that in another video. And this took 21 hours. So when you put this guy together and Darth Vader is looking at you, realize that this is about 24 hours of printing. So lesson number 1, this is not a fast process, but it is fun. It's fun to watch. So I'm going to put him off on the side. Okay, my wife and I, the whole family, are real big fans of Harry Potter, the Hogwarts series. This is also on Thingiverse, and it's the Deathly Hallows charm. And this is the capability of the printer. The center, this is all one piece. The center circle on this thing spins. Kind of cool. Really neat. And it's set up to be a necklace. It put a little hole in the top. Set up to be a necklace or a charm. And my wife found this, and this is what we're going to look at in detail. My wife found this switch plate on Thingiverse and said, go for it. So we loaded it in, set it up to print, and this one took like 7 hours and 56 minutes, almost 8 hours. So this is not real fast. The 3D printing is not real fast, and it's not real fast because it's taking 1.75 millimeter filament, which you'll see over on the printer, which is 1/16 of an inch in diameter. It's heating it up, turning it into a liquid mass, and putting it out on a very, very fine line, and then putting it in a particular place. And the way the whole system works is it builds out in layers. So it has to build the first layer, then the second layer, then the third layer, and I address it later on. When it comes up to these letters, it has to build the letters in layers. So it puts a layer on the top, layer on the bottom, layer on the top, layer on the bottom. It can't come in and do all the letters, all this letter, and then come down and do all this letter. It doesn't work that way. Maybe it could in the future. I don't know. Okay, so one of the major assets with the Pressa system that I really, really liked was in the assembly, they give you this book. And this book is really well documented. This book is super. I have some issues with it, and I'll show you those at the end of the video, because when we get back into hooking up the wires, back on like pages 122, these arrows and colors are buried inside the images, and for somebody who's slightly visually impaired like I am, it's really tough to find them. I'll show you those in detail at the end of the video. They also give you this operations manual, printing handbook, and really good, really useful reading. So this particular printer is very, very well documented. One of the issues I do have with this is because the print time is so long, and you're going to be sleeping with this thing while it's running. I'm concerned because it's hooked up to the electrical system on the internet, and I didn't create this on the internet. Somebody came up with how to hook this up to a smoke alarm with a relay box so that if the smoke alarm goes off, it shuts off. And because this thing will do auto recovery, as I understand it, this relay box stops it from coming back on. I'm probably going to do a video on this because the instructions are pretty good, but not quite clear. And I love making things correct. So with that, what we're going to do is we're going to step off into what I think is a pretty complete process of going on the internet, finding some files, downloading them, turning them through Slicer into G-code, from STL format to G-code. G-code is what the system reads. Prepping the system, doing a first layer calibration, just so you know what it looks like. You have to do that every once in a while, not all the time, and then watching the system run. And it's going to take a while. When we jump to the production videos, it's not continuous. Because the production time is 8 hours, I have 20, 30, 40-second clips at various points just to show you how it's going. So let's continue into the next phase of this video. Thanks. This is my Pressa Mark III S Plus 3D printer. It's sitting in my living room at the moment. It prints really quiet. I don't smell anything. Nobody complains about any odors. Does not interfere with the television if they're watching television. The home page for Pressa is prusa3d.com. San Diego Fine Woodworkers has two URLs, one for club information, the other one is a member forum. They may require sign-ins and membership. One of the things I highly recommend you do if you're going to get involved with this,
unless you're extremely knowledgeable, is become associated with a mentor, whether it's an individual who knows how to do this or a group who knows how to do this. There is a learning curve to this, and mentors, coaches, YouTube, extremely helpful in getting through some of those learning curves. And if Amazon doesn't sell it, YouTube has a video on it. If you go over to YouTube and just search 3D printing, you'll find thousands of videos, including mine, and many of them are extremely helpful, very informative, and really sparks off your imagination. I've just initiated the first layer calibration run, and you're going to see the 3D printer find its 9 reference points. There's magnets underneath the board that silver and black sensor on the print head pick up, and they set the XYZ length, width, height for the printer, and then the printer comes back and puts a test line on the extreme front left corner of the bed, mesh bed as it's called, and that's just to get flow through the nozzle and to start a flow. And then it goes and prints a zigzag pattern, which I've cut so we don't have to watch all of it. And then it goes up and prints in the upper left corner of in the front left corner of the bed, mesh bed. It prints a rectangle, and that allows you to adjust the height of the nozzle, which affects the width and thickness, height of the filament run. In this video, I have a slight issue with that, and I adjusted it very slightly. It's done in millimeters. I adjusted it by 0.020 millimeters, very small, but that's how critical this is. I've moved over to thingiverse.com, a major resource for items to print up in the files, and searched in Harry Potter, and I found the light switch cover that my wife wanted printed. So it's down here. I'm going to select it, and it'll come up and it'll give me another screen, and it'll say, do you want to download all the files? And the answer is yes, I do. And then my system is going to come up and ask me if I really want to download this, and the answer is yes, I do. So it now downloads it to my hard drive, and at this point it's already over there, so we'll go over and look at it. The file downloads as a zip file, and I've saved it off to a specific directory on my hard drive, and then I've unzipped it, and that's what you're seeing up here as Harry Potter Light Switch 2021-08-10. And these files, this group of files, some of them you're going to find this block to be very well documented. You'll see many things inside of them. On others, you'll just find the STL, and it'll say, hey, this is what I created, which is okay. Some of them are really well documented. Some of them are, hey, this is my production run, have at. They're all free, so appreciate what the creators did for you. So I downloaded the zip file, extracted it into a directory that I prefer, and now I'm going to bring it into Slicer. One of the reasons I bought the Pressa printer is it comes complete, and it comes compatible. It's using its own software. So in the Pressa Slicer, which you saw the opening screen just moments ago, I'm going to come over here, I'm going to click on File, I'm going to click on Import, and come over to here, Import STL. It comes up to the directory of Harry Potter Light Switch. I'm going to click on the STL and File, and I'm going to click Open. And at this point, it's on the system. From here, I can do a lot of various things with it. If I click it, I can move it around, and have some fun with it. And if you want to print it over here, if you want to print 2 of them at one time, you can. As I said, this is an 8-hour process. Over on the right side, my system is set up. I'm using PLA as a filament and Mark 3S as my printer. Infill is 15. I just leave it that way. I leave Brem to be set as a default. It's going to print on everything I've got. It just increases the adhesion of the object to the mesh bed. And if I want to change the size, I can come down here and increase it either by percents or increase it by size, and this locks the ratios in. If I want to deal in millimeters, I can remove the check. If I want to deal in inches, which I prefer, I can leave it checked. And then I am going to select Slice Now. When it slices, it does it really quick, and it comes up with a whole lot of things that we're going to see. And among others, these are all the layers, and they're all color-coded. And when you look back at the image, the object here, it'll tell you what your layers are and how you're going to go. And here's the brim that it's putting on it, and it's telling it support material interface is down here, and it's telling you everything you need to know, so to speak. I'm not going to get a whole lot into it. Other people are very, very knowledgeable at this. I generally take the defaults. The next thing I want to do is I want to export the G-code. So I'm going to click Export, and I want it to come back to the same directory that I had. So I'm going to come over here, and because I've got some already up there, because this is not the first one, I'm going to make this C. So it tells you when it goes to save it what its estimated production time is. And this time here it's 8 hours and 28 minutes. So I'm going to click Save. And now we have, when we go back over to our directory, we have our C file. Not sure why, but we went from 7 hours and 56 minutes to 8 hours and 28 minutes. Whatever reason it did that, it did it. So pretty happy. Now what we need to do is we need to load it into the SD card, because these are on my hard drive. We need to load it into the SD card and then take it to the printer.
So as stated or implied, this is a very sequential process, and the next process we have here is we need to clean the table. I'm going to use isopropyl alcohol, and when you buy this stuff, make sure it is isopropyl alcohol and not rubbing alcohol. If it says rubbing alcohol on the label, it has oil in it, and the oil interferes with the adhesion of the table. So what you do is you take some soft element, tissue paper, toilet paper, paper towels, and you get alcohol on it, and you clean the table without touching it. Clean the table. Try to get all of it. We're printing in the center, so clean the table. It's done. This thing needs to be disposed of properly. I'll take care of that as soon as we get into the next step here. Now I'm going to turn the power supply on, and Carissa is very nice about giving you the SD card. It's got some sample files on it. I've been using it to transfer stuff over. It goes in, some people call it upside down. I agree with that. It goes in with contacts forward on the left side of the display. And the next thing that comes up is sorting the displays. So I'm going to show you what these are. It sorts the displays in several ways, and what we're going to do is we're going to push the button to bring us up to the menu, and we are going to scroll down to Print from SD. We're going to click Print. It's going to take us to the main, and we're after Harry Potter switch, and it gives us some data. We're using PLA, and we're in the Mark III at 7 hours and 56 minutes by the G-code process. That's the estimate. So we're going to click, that's what we want to do. It's checking the file. Now it's going to bed heating. While it's heating, I'm going to put you back on the tripod, and we'll catch the rest of the action. The bed is heating, and when it comes up to temperature, it's going to run some processes of checking its own alignment, and those are what were required or done in the setup and the adjustments, and then it's going to start printing, and I'm just going to let it run. Status report, because it tells you what it's doing. The nozzle's up to 217 degrees centigrade. The bed is up to 56 degrees centigrade, so it's got a couple of degrees to go. Its target temperature is 60. The nozzle's already up to temp. And when they say this thing consumes power, it consumes power because of the heat. It's now checking its alignments based on those magnets that are in the bed. It's really cool. It's happy with that. This first line is just to clear the nozzle and to get the filament as a fluid coming out of the nozzle. And if this is really screwed up, it's time to stop, start the process over again. It looks good right now. We have brimming set on this print, and that's what it's putting out right now. It starts from the outside and works its way in, or it starts from the inside, works its way out. It's up to the software. You don't control that. And according to the menu, we have 7 hours and 55 minutes remaining in this. I'm going to let it run for a minute. We'll zoom in so you can see it. One of the reasons it takes so long is that filament is coming out very thin, both in all dimensions, X, Y, Z. And it's putting down layer after layer, but it has to get the first layer complete before it can start the second layer. We're going to come back in recurringly throughout the period and look at this, and we'll see how it goes. It's interesting to see, and you can see in the development software for this, the order that it's actually going to do these layers in. This is a switch plate, as I showed you earlier. My wife wants it. It's associated with Harry Potter. And those are the two screw holes that are going to hold the switch plate to the switch box. In the process of putting down the first layer, it's defined that dimension. Kind of cool. And sometimes things go wrong, and this is an example. For some reason it's grabbing itself and pulling through, so we'll have to see what happens. So the system is back to checking its alignment. Does this every time. Now it's going to run that first strip, and this is just to clear the nozzle. And it looks good. Now I'm going to go in and on the display, which I can't quite get to. I'm going to lower So I've just lowered the print head 1.655. It's progressing. It's showing 7 hours and 33 minutes left in its print process, and just came back to check on it. Kind of interesting to watch what patterns it's in the software. You can see what patterns it's going to do when. Just put another layer on the screw slots, on the screw holes. Just a video update. We're at 6 hours and 55 minutes remaining according to the screen software, and the system is just off and running all by itself. That rim around it is called the brim. That adds to its cohesiveness to the table, stops that previous failure which I showed you. Off and running. I'm off to read. We'll check in later. Still spooling away according to the screen. 6 hours and 13 minutes remaining. Just keeping an eye on the printing. Right now we have 5 hours and 48 minutes remaining, so kind of fun watching it do its thing. And it says we're 27% of the way through the print file. And we're now at 32% according to the screen. 5 hours and 22 minutes remaining. And it's just making its way through the system. Going to change the angle just a little bit. 5 hours and 21 minutes, 32%. Just having fun. Reading the screen, we're at 41%. 4 hours and 39 minutes remaining. That's an estimate. And the printer is working on a diagonal pattern now. It interlaces at angles, different layers for strength. It does that in the slicer mode. It's all done for you, so you don't have to figure it out. Pretty cool. Just to check up on our printing, right now we are at 4 hours remaining. It's showing 49% complete through the file. One of the caveats is that doesn't take into account how long an individual command line may be, so it's close. As other videos will tell you, a file that says 4 hours may take 4 hours and 8 minutes, or may take 3 hours and 52 minutes, because the length of the command lines may affect how long it actually takes to accomplish. But right now we're at 49%, 4 hours remaining. Just taking its time.
I'm just guessing that the reason that it went to this wave pattern was because of the fill option. Splicer tries not to build solid objects. That increases printing time, increases the the weight increases the use of filament, and it's probably trying to reduce that, so it had the intention of building a solid layer over these prints, and it may have done that. If you remember the Deathly Hallows charm, it has the ability to make holes in things. Kind of interesting.
That's showing 62% complete through the file. 3 hours and 1 minute remaining, and it's just working its way through. This is a fast process. Total sarcasm. It's an interesting process, but it's a fast process. It's a slow process. Okay, we are showing 68% complete. That's through the lines of code, and it's estimating 2 hours and 30 minutes left. One of the advisories, as I was thinking about this, is in 5 minutes you're seeing what took 2.5 or 3 hours by the printer to generate, because I'm shooting snippets that are probably 30 to 40 seconds long each. So the printer is just working along its way. So status report, the screen is showing 74% of the code lines completed, showing approximately 2 hours remaining, and it's still working on the basic switch plate itself. Just off doing its thing. The display is saying 81% of the code lines have been executed, an hour and 30 minutes remaining, and it's off just doing its thing, building another layer on the front of the switch plate. Now we're just watching it work. It says 93% of the code lines processed and 30 minutes remaining, and we're just kind of having fun just watching it do its thing. It's putting the words on the plate now. Seven hours and 56 minutes according to its calculation. It's usually pretty close. We'll see. Okay, the display is showing 3 minutes left, so it's getting close. Where it's going to end, exactly when it's going to end, who knows. 99%. This is a close to 8-hour project, 7 hours and 54 minutes or whatever it was. It'll tell me again here in a second in the display, which is really helpful. Tells you how long it's been running. Seven hours and 56 minutes, that's an estimate. Actually, the 3 minutes remaining is an estimate, 99%. One of the options you can do through commands is you can change the color of the filament as you go. You can do it manually, or you can buy an add-on, an accessory, which will take up to 5 colors at one time, and then control what color you want, where and when by layer. You cannot control through Splicer to be the bottom letters one color and the top letters another color. You can do that with a paintbrush, but Slicer says each layer is one color, period. You can't segment the layer into a north, south, east, west, and do it that way. Right now it's showing less than 2 minutes, and I'm going to let it run So you're probably going to see it jump so that we catch the end of the process. That jump from the top to the bottom, remember it does layers at a time, so it can't go to the top, do all of the top letters, and then come to the bottom and do all the bottom letters. It does each layer across the entire plate in sequence, in entirety. And it's done. Okay. Going to let it cool, and then we'll come back and we'll show you popping it off the plate. The plate is metal. It's heavy steel. Probably I'm going to guess it 16-20 gauge steel. When it cools, you can flex the mesh bed, as it's called, which is textured on my system, and that should pop off. And then the brim will be easily removed. Remember, I put the brim on to increase the adhesion to the plate, and it usually works. Okay, we'll come back and catch it after it cools. Okay, we've given it some time to cool just in case. The mesh bed is magnetic; it sticks, and as I said earlier, they come off. You just bend it; it's already loose. It's off. That's how quick it comes. Mesh bed goes back. This is the brim, and it normally comes off pretty easy. On the previous stuff, it's come off pretty easy. So there we go. Looks like we might have some touch-up work to do with a razor knife. Maybe not. Maybe this will pull it. Maybe this thread will pull it. That will. And still a little touch-up work to do, a small file, whatever. And a switch plate, almost 8 hours of print time, made out of PLA, supposed to be very strong, whatever, really nicely textured. It looks good. Now I get to turn it over to my wife, who gets to paint it and put it up somewhere. So a Harry Potter switch plate, only close to 7 hours, close to 8 hours of production. And that's the back of it if you want to see what it did to the back. Okay. Sound good? Thanks. Bye.
And I said I had some issues with the assembly manual, and these two images show basically what they are. The print on these is rather small. That coin in there is a US quarter. It's just over 1 inch in diameter. And inside these images, there's arrows that are very hard to pull out of exactly where these wires are supposed to go. Okay, they're all called polarized. They're all sized, so it's really tough to get A into B and B into A. So it is tough to get them in the wrong spot. But it's tough to find the right spot, and it sure would be nice if these arrows came outside the image, so that you could follow the arrow into its target rather than have the arrow buried inside the image. However, I go back to, it's a really well constructed, clear manual. I wish they would have actually made their prototype for the manual a rainbow, many color parts, so that you could see where the parts go, because a lot of them are black and you're putting a black on a black part, and it's just fun for those of us that are slightly vision impaired. But it's a good manual, just it could just help us a little more. So total involved in this, taking it over to thingiverse.com, downloading the file, extracting it, creating the special directory. I use special directories to hold files, and then taking it through Slicer, and then taking it over to the Pressa 3D printer and printing it. It was probably close to 9 hours for a switch plate. Here are some of the URLs that should be of interest to you, including my home page, which I have stuff on. In the near future, I'll probably be putting a 3D tab up there, but a lot of my woodworking stuff is up there. So I hope this video is helpful to you. I think it's a fun activity. It's beneficial. Lots of variety, lots of capability in this program. Thanks for watching.